All right, Bismillahirrahmanirrahim. Today we are going to start with the very first chapter of physical chemistry called atomic structure. In atomic structure, we will be learning the detail, discussing the detail of how atom looks like, what is present inside the atom, where does the protons, neutrons, and electrons are present, and what is atomic number, what is atomic mass, isotopes, what are the relative charges of uh, protons and on the neutrons and on the electron, and what are their relative masses. So let's start with the shape of atom. We know that atom has a positive center called nucleus, and there are circular orbits around the nucleus known as shells, right? So we can say that has to be right in the middle. So the central part of the atom is called nucleus. This is nucleus. And we know that nucleus holds protons and neutrons, and these two particles make atomic mass. This is called atomic mass. So something which is present inside the nucleus, known as nucleon number, because they are present inside the nucleus, and also since they make the mass of atom known as atomic mass. Now, around the nucleus, these are hypothetical circular orbits. They are not exactly like koi circles hote hain. These are just a hypothetical pathways around the nucleus in which we assume that electron revolve, right? And in the first shell, we know there are 2 electrons. In the second, we have 8, and so on, right? So we assume that most of the area, let's imagine this is the total size of the atom, which is occupied by this very atom. And as I mentioned, electrons are very negligible amount of mass hota hai electrons ka. And these shells are basically nothing. These are just a hypothetical pathway. So if the total volume occupied by the atom is this much, उसमें जो actual mass होगा वो तो ये है. This is the actual mass. So we can say that the actual mass of the atom is negligible as compared to the mass of the the whole atom. So most of the space occupied by the atom is empty. Most of the space occupied by atom has to be empty. क्यों empty है? क्योंकि सेंटर में न्यूक्लियस बहुत छोटा सा, उसमें प्रोटॉन्स और न्यूट्रॉन्स हैं, और शेल्स भी मोस्टली आप देख रहे हैं खाली हैं. इन द फर्स्ट शेल देयर आर ओनली 2 इलेक्ट्रॉन, बट देयर इज अ ह्यूज एरिया दैट जो उन्होंने ऑक्युपाई किया हुआ है. एंड देन वी हैव द सेकंड शेल जिसमें बहुत ज्यादा एरिया एंड ओनली few number of electrons. So atom as a whole, it is a neutral particle. Why atom is neutral? Anyone in the class? Why atom is neutral? Yes, Rayan se पूछ रहे हैं. Yes, Rayan. Why do you think atom is neutral?
Sir, positive protons होते हैं, electrons होते हैं, इनका number equal होता है, तो overall charge होता है.
Excellent. So when you look at any particular atom, let's talk about sodium, atomic number 11 and mass number 23. So there is no charge on this particle. It is because the proton number, which is the number of proton, are the same as the amount of electrons. So jitne positive particles hain, we have exactly same amount of negative particles. So atoms overall electrically neutral. But you can remove or add the electron, just the electron. We cannot add or remove the protons. So you can add or remove the electron to make atom electrically neutral, which are called ions, cations or anions. So atoms are neutral because the protons are the same as the number of electrons, correct? Now, we know that with every single particle, this is from O levels, with every single particles, there are 2 different digits associated. Like I said, sodium ke saath 2 hai. The smaller number is always known as atomic number. And this body value is called atomic mass, right? Atomic mass is the sum of protons and neutrons. Atomic number is just the protons. And it is the same as electrons if there is no charge, right? Now, let's compare all the particles. Atomic mass ko hum kya kehte hain? It is actually known as relative atomic mass. That's the exact name. This is relative atomic mass, normally known as AR. It is also known as nucleon number. Nucleon. This is also known as nucleon number. So relative atomic mass represented by AR. It is the sum of protons and neutrons. Atomic number is just the protons. And for a neutral atom, which is electrically neutral, it has the same amount of protons and electrons. Just for a revision, we know that this simple element have 11 protons. There is no charge, so it must have the same amount of electrons. And how to get the neutrons? You can find the difference of these two values. So subtract atomic number from atomic mass, you will get the neutrons. Make sense, everyone? Yes. So, yes, Ryan.
सर आपने बोला कि रिलेटिव एटॉमिक मास। सर मुझे कंफ्यूजन होती है रिलेटिव में, हम कहते हैं कार्बन 12 के साथ कंपेयर हो रहे हैं, जैसे कार्बन 12 का कैसे मास निकला था एंड हम कंपेयर कैसे करते हैं, मुझे इस चीज की समझ नहीं आती, ओ लेवल से नहीं आती थी, लाइक कार्बन का कैसे निकला।
That's a very good question. बेसिकली कार्बन का भी निकला नहीं है, वैसे हम इसको स्टोइचियोमेट्री में डिटेल में भी डिस्कस करेंगे, बट क्योंकि अभी आपने पूछा है, कार्बन का भी निकला नहीं है. We know that atoms are so small. If this is a dot, if you see this dot, even this single dot would have trillions of atoms. So अगर इसमें millions or trillions, that imagine the size of one atom. That means one atom is very small, that you cannot see that atom with the naked eye. और उसी टाइम पे मैं कहता हूं कि one atom of sodium weighs 23 gram. 23 gram is a big number. तो या तो फिर ये वाली स्टेटमेंट इनकरेक्ट है या ये वाला मैथ इनकरेक्ट है, बिकॉज एक साइड पे हम कह रहे हैं एटम्स आर वेरी स्मॉल, ऑन द अदर साइड वी आर सेइंग दैट one sodium is 23 gram, one magnesium is 24 gram, one iron is 56 gram. These masses are actually, जिस तरह अभी रयान ने कहा, these are not the exact masses but the relative atomic masses. So कार्बन का इन्होंने पूछा कहां से आया. देखो, this is just for our benefit या अपने एडवांटेज के लिए साइंटिस्ट डिजाइन a particular, उन्होंने डिजाइन किया कि लेट्स इमेजिन हमने कार्बन को कह दिया कि कार्बन भाई तुम हो 12, कार्बन इज अ स्टैंडर्ड 12, राइट. ऐसा नहीं है कि कार्बन का 12 ग्राम एक्चुअल मास, इट्स नॉट. if you look at if you know गूगल करो या चैट जीपीटी करो, you would see कि कार्बन इज एक्चुअली नॉट 12, दिस इज जस्ट अ मास. हमने ये देखा कि हमने वी वे एक्चुअली कार्बन, और कार्बन को हमने स्टैंडर्ड लिया और उसको वे किया अगेंस्ट एवरी सिंगल एटम. सो जब हमने कार्बन के अगेंस्ट मैग्नीशियम को वे किया तो मैग्नीशियम वाज एक्चुअली ट्वाइस हैवियर. मैग्नीशियम वाज ट्वाइस. तो हमने इफ वी अज्यूम कार्बन एज 12 एंड मैग्नीशियम वाज एग्जैक्टली डबल, तो हमने कहा मैग्नीशियम इज 24. एंड उसी कार्बन के कंपैरिजन में हाइड्रोजन वाज 12 टाइम्स लाइटर, तो हमने कहा हाइड्रोजन इज 1. These are not the exact masses. These are the masses in comparison with the carbon जिसको हमने assume किया this is carbon 12. That is why they are called relative. लेकिन इसको हम next chapter में detail में भी discuss करेंगे because that is part of the syllabus now. So those who have just joined, we have just started with the first chapter and the first concept of atomic structure. In an atom, you all know from your basic classes that the central part is called nucleus, which holds the protons and the neutrons. The circular parts called shells in which electron revolve. So most of the space occupied by the atom is empty. आप देखो एटम में ज्यादा एरिया आपको कनाडा की तरह या ऑस्ट्रेलिया की तरह empty नजर आ रहा है ना. I mean there's just the land. You know the population of Australia, anyone? Considering the population of Pakistan is around 30 crore, 25 crore to plus है. So anyone with the right guess, what is the population of Australia? And imagine it has the entire Pakistan, India and Bangladesh. इनकी सारी land को आप add करें, Australia is still bigger than the whole subcontinent. So what, any guess, Aksa, about the population of Australia? Don't Google or chat GPT. No idea? Yes, Sarim Khan. Park Studies में क्या grade आया था सर? Yes.
70 million.
70 million. कितने होते हैं 70 million? 7 crore maybe? I think मुझे याद है जब मैंने चेक किया था some 3-4 years back, तो ऑस्ट्रेलिया की entire population was equal to कराची और लाहौर की population. कराची की population around 1.5 crore और लाहौर की population around 1.2 or 3 crore. So it was like around 3 crore, which is about 30 million. It was like 5-6 years back. I don't know अब क्या होगी. So imagine कितनी ज़्यादा land है उनके पास, and look at the exact number of people that live there. So that's why it is very similar to atom. Most of the space occupied By Australian is empty. Atom is neutral. It is because the number of protons is equal to the number of electrons. जितने protons है उतने electrons है तो overall neutral हो जाएगा. Every single atom in the periodic table is associated, with two different digits. One is called atomic number. The smaller number is called atomic number, and those are basically the number of protons. और एक atom में जितने protons होते हैं, it has exactly the same amount of electrons if there is no charge. But the bigger value is called relative atomic mass, and it is nothing but the sum of protons and neutrons. Now we can find the protons, neutrons by very basic, जिस तरह O levels में आपने किया था, जो छोटा number है, these are the number of protons. We have the same number of electrons, and the difference of these two values will give you the number of neutrons, which is called atomic mass. Let's now compare, all subatomic particles, which are called electron, proton, and neutron. Let's imagine you place all these particles in an electric field, a field generated by electric charges. And we know that when there is a field, there is a positive end and there is a negative end. Let me just इनको थोड़ा नीचे ले जाते हैं. So, and imagine you have a source of the particles from where you are generating the particles. You are generating all the subatomic particles, and you are उनको आप throw कर रहे हो. You pass those particles from that electric field, and we see there are few particles which passes without any deflection like this. There are particles which deflected very strongly to the positive end, and there are particles which deflected to the negative end, but their angle of deflection is very small. So those particles which deflected, which passes through undeflectedly, they are neutral particles. Why they are neutral, Dr. Ryan? Why these particles are neutral particles? How do we know from this experiment they are neutral? Ryan.
Sir, क्योंकि वो straight जा रहे हैं, neither attracted to the negative ones or nor the positive ones.
Yeah. So if a particle is not attracted toward any end, that means it is chargeless particle. Chargeless particle. And we know chargeless particles are called neutrons, right? And the particle attracted toward the positive plate, they are negatively charged particles called electrons, because electrons are negatively charged particle, and only negatively charged particle can attract the positive particles, right? And the particles attracted toward the negative plate are nothing but protons, Amna. But if you look at the difference in the angle of deflection of electrons and angle of deflection of protons, what does this tell us if we have Jannat with us? Yes, ma'am. What does this tell us about? Does this, it is something about their mass or about their charge, or what does this angle of deflection tells us about these two subatomic particles, Jannat?
It shows their size, maybe.
Like, how would you compare the size? I mean, protons are heavier or electrons are heavier?
Electrons are less heavier because they get deflected more.
Yeah, excellent. Imagine you have a Ferrari and I have a big trawler. So हम race लगा रहे हैं and there is a sharp turn. So Ferrari to, small in mass, it will take a sharp turn because it is lighter in mass. So from this very angle of deflection, हमें charges का भी idea हो रहा है, and we also, हमें ये भी पता चल रहा है कि electrons are very light particles because they are getting deflected more. Sharp turn आ रहा है compared to protons, which are heavier particles. So from this experiment, we can conclude two different, results. One is, provided from the source, we provide the same velocity for all the particles, right? So let me draw a table and compare. This is the exact same table that you drew when you were in your IGCS, your O levels, that you have protons, you have neutrons, and we have electrons, right? So let's compare their masses, but these are not the exact masses, but the relative masses. And let's compare the relative charges as well. So if you talk about relative mass, I mean, if the mass of proton is 1, neutron must have almost same. हम A levels में same ही consider करते हैं, actual में होते नहीं, but there's a very negligible amount of difference. So we can say that proton and neutron weighs the same. But whatever the mass of proton, divided by 1840 is the mass of electron. तो इसको मैंने explain किया था, those who are with me since O levels. Imagine this is your proton. This is the mass of proton. Imagine, look how big this is. This is the mass of proton. तो इतना ही mass किसका होगा? न्यूट्रॉन का. But imagine हम इसको chop करें और इसको chop करके इसके कितने pieces कर दें? इसके कितने pieces करें chop करके इसके? We divided this into 1840 pieces. One piece अगर इसके 100 pieces करेंगे ना तो शायद एक piece नजर भी नहीं आएगा. 200, 500, 1000, 1840. तो imagine एक piece तो शायद इतना small होगा कि नजर भी नहीं आएगा. So that would be electron and this is proton. So compared to this proton, that mass would be negligible. That's why while weighing the atoms, we ignore the electron. We always consider the protons and neutrons. And protons and neutrons are called, together they make the atomic mass. देखो आपने कभी सोचा कि भाई when we are measuring atomic mass, अगर atomic mass measure कर रहे हैं तो we must measure everything present inside the atom. We must measure the protons, the neutrons, and the electrons. But we always ignore the electrons. We always weigh the protons and neutrons because electrons are very light particles that their mass can be ignored. So relative charges, we know that proton, if it is not the exact charge, if proton is +1 or +2 or +10, whatever the charge on proton, electron has the exact same but opposite. And you all know the neutrons are neutral. They are charge-less particles, right? So this is something, a very basic introduction about, the electrons, protons, and neutrons. There's a very important concept about the distribution of the charges and masses. Yes, Ryan?
सर यहाँ पे भी बताएंगे relative का मतलब क्या होता है?
Relative का मतलब होता है comparison में. For example, you all are enrolled in A levels. तो आप पे जो grades आएंगे, those are not, अगर आपने 90 भी score कर लिया in out of 100, तो we are still not sure कि हमारा A आएगा या स्टार आएगा या B आएगा, until कि आपके साथ वालों से आपको compare किया जाएगा, right? So इसको हम कहते हैं relative grading. If someone scores 60 out of 100 and no other student can cross 60, then 60 would become A or A star. And in comparison to 60, the other student will get the grades. This is called a relative grading. Similarly, if proton is +1, electron must have the same. उसी के comparison में, proton के comparison में electron का जो charge है, इसको हम कहते हैं relative charges. In comparison. So they are in comparison to each other. Proton against electron and electron against protons. Make sense, Ryan? Yes.
जी सर. Thank you.
So now we have the distribution of, this is very important. I want everyone to read the entire statement and try to answer the question. Distribution of charge and mass in an atom. Right? So the statement is about how the mass is distributed in the whole of atom and how the charge is distributed in the whole of atom. Let me draw an atom. You all know that there is in the center positive charge and we have shells. And we've just learned that almost all of the mass of atom, almost all of the mass lies inside the nucleus in the form of protons and neutrons. So we can say that because electrons have ignorable amount of mass. So almost all the mass of atoms lies inside the nucleus. Because only nucleus holds the protons and neutrons, and protons and neutrons are 1840 times heavier than electrons. And we can say that atom ka jitna bhi mass hai, that is present actually inside the nucleus. What about their charges? The charge is distributed in such a way that the positive charge is present here inside the nucleus in the form of protons, and the same amount of negative charge is distributed in the shells, right? So the positive charge, we can say that the positive charge lies inside the nucleus, and electrons, negatively charged electrons or negatively charged particles, which are called electrons, revolve around the nucleus. Revolve around the nucleus. Makes sense, everyone? Right? So how the mass is distributed? The mass is distributed, almost all of the mass lies inside the nucleus, whereas the charge is distributed in such a way that the positive charge is present in the nucleus and electrons, which are negatively charged particle, revolve around the nucleus in one of the fixed circles called shells or orbits, right? That is it as far as the introduction of atomic structure is concerned. We have just learned the basic structure of an atom, how the atom, where the mass and where the charge lies inside the atom. Why is atom electrically neutral? I mean, how to get the protons, neutrons, and electrons. What is atomic number and atomic mass? How would you carry out the experiment inside the electric field? And then how would you, check the results based on the experiment, that which atom is neutral, which is positively charged and negatively charged, which one is lighter and which one is heavier, right? And again, how the charge and mass is distributed. Let's now talk about a very important, actually important concept in the periodic table, which is about the change of atomic radius when you move top to bottom or across the period. So let's first talk about the groups and periods, something about your O levels. I hope you can recall the concepts of groups and periods. Anyone in the class? Mic is open. What are groups in the periodic table?
Groups are the
Yes, sir.
horizontal lines of atoms, while periods are sorry. The groups are the vertical ones, and the periods are the horizontal ones.
Excellent. So groups are the vertical columns. I hope you all can, recall the idea of the groups. I mean, the group 1 starts with lithium, then we have sodium, potassium, rubidium, cesium, and francium. So this is group. And let me write the element of period 3, for example. So after sodium, we have magnesium, we have aluminum, silicon, phosphorus, sulfur, chlorine, and argon. So this is a specific period, which is called period 3. Now we are going to discuss the atomic radius when you move top to bottom in a group, or when you move across the period in the same period from left to right. So the concept is of atomic radius, and let me tell you, this is very important. This single topic will connect बहुत सारे और भी topics, will help you to understand those other topics as well. So the idea is, as you go top to bottom, groups को पहले discuss कर लेते हैं. The atomic radius increases. The atomic radius increases top to bottom, right? So this is just an information. Atomic radius increases. Thanks so much. We need to know the reason that why does the atomic radius increases when you go top to bottom. So let's explore the reason. We all know that the atomic number of lithium is 3, sodium is 11, potassium is 19. चलिए यहाँ तक रखते हैं इसको. Let me write the configuration for lithium. अभी मैं O levels वाली लिख रहा हूँ, which is 2,1 with atomic number 3. We have sodium with atomic number 11. So the configuration must be 281. And for potassium, it is 19. So let's assume कि 2881. So if you look closely on all 3 atoms, particularly with their configuration, you see that lithium, how many occupied shells does lithium have? Ryan, how many occupied shells does lithium have? Occupied shell of electrons. 2. Sodium have 3. Potassium have 4. So as you move to the next atom in the same group, an extra shell is added. Iska 2 shells hai? This has 3 occupied shells. This has 4 occupied shells. So badi obvious reason hai. As you go down, atomic radius increases. Number 1 is extra shell is added. extra shell is added. So when extra shell is added, important everyone, the shell which was initially valence shell, outer shell, it has now become the inner shell. Now imagine, Amna, we have nucleus in the middle, we have shell, first shell which hold maximum of 2 electrons, the second shell which can hold a maximum of 8, usse kam bhi ho sakte hain. But let's understand the concept of shielding effect. Look, nucleus has a positive charge. It would attract the electron of the first shell, and it would attract the electron of the second shell, the third shell, and the fourth shell. But the amount of attraction for the first shell electron would be greater क्योंकि वो उसके ज्यादा करीब है. Second वालों के लिए थोड़ी weak होगी क्योंकि दूर है. Third वालों के लिए और weak. But nucleus is going to attract every single electron, and that's why electron revolve around the nucleus, like our Earth revolve around the sun. प्रॉब्लम ये होगा कि जब ये वाले न्यूक्लियस सब इलेक्ट्रॉन को अट्रैक्ट कर रहा होगा, बट प्रॉब्लम ये है कि ये जो इलेक्ट्रॉन सेकंड शेल फर्स्ट शेल के हैं, इनर शेल के इलेक्ट्रॉन्स, दीज इलेक्ट्रॉन्स आर ऑलवेज नेगेटिवली चार्ज. ऐसा ही है ना? तो बाहर वाले भी इलेक्ट्रॉन्स है, वे भी नेगेटिवली चार्ज. तो जब न्यूक्लियस इनको अट्रैक्ट कर रहा होगा, उसी टाइम पे इनर शेल के इलेक्ट्रॉन्स विल स्टार्ट रिपेलिंग द आउटर शेल इलेक्ट्रॉन बिकॉज ऑफ द सिमिलर चार्जेस. तो क्या होगा? व्हेन दिस रिपल्शन वुड अकर, would the second electron and this electron, would it become closer, or do you think it goes away from the nucleus? Aksa, what happened to the outer shell electrons? Aksa. Shabash. I hope you all are listening. मैं सिर्फ बोल नहीं रहा. Yes, Shabash Aksa. Yes, Jannat. What would happen to this valence electron? Would it come closer as a result of repulsion from the inner shell electron? Or do you think it goes away from the second shell, from the first shell?
Like,
your voice is lagging. I can't hear you. Yes, Sarim, you want to say something?
Richard, do we have to factor in that if the repulsion force is greater than the attraction of the nuclei?
Mm-hmm. Mm-hmm.
So I mean, if the repulsion force is greater, then it would go away, and if it's less, then it would come inside.
I mean, that's an excellent answer. Sarim says if we need to see the repulsion and attractive forces, but look at the advantage of repulsive forces compared to attractive forces. Repulsive forces are present closer to the electron. Attractive forces to center में है ना. So होगा ये कि these inner shell electron, these electron present in the inner shell, everyone, please listen, the inner shell electron will repel the outer electron and outer electron goes little away. ये तो पहले इसके पास तो है ही दो electron to repel. If you look at the next atom, since we have more inner shells, more inner electron, these 2 electron will repel these 8 electron, and together all 10 electron will repel this 1 electron. तो ये electron तो बहुत दूर चला जाएगा. तो what would happen to the atomic radius? It would definitely increase. नीचे आए, in the next atom we have 18 electrons. All these electrons will repel this 1 electron. ये तो बहुत दूर चला जाएगा. So what would happen eventually to the radius? It would increase. This effect of repulsion is called shielding effect. And as you go down in the periodic table, in the same group, the shielding effect increases. It increases due to increase of inner shell electrons. तो मैं यहाँ पे लिखूंगा, extra shell is added, due to which shielding effect increases. So this, अभी मैं shielding effect की definition भी लिखवाता हूँ सबको. Due to which shielding effect increases, so outer electron goes further away. Further away from nucleus. So we can say that nuclear pull decreases. Nuclear. So if something gets away from the nuclei, the nuclear pull will decrease for that particular electron or for that particular shell. So nuclear pull decreases. अच्छा मुझे बताएं, if nuclear pull decreases for any particle, let's say in तीनों particles में, from all these 3 particle rayon, which particle's electron will face the weakest repulsion from the nuclei and why?
Sir, lithium, I believe, would have the least repulsion क्योंकि उसके पास सिर्फ attraction है. While अगर हम
मैं ये
लेते हैं
पूछ
जी जी
या
जी सर.
मैं ये पूछ रहा हूँ, द क्वेश्चन इज अबाउट द न्यूक्लियर पुल, न्यूक्लियर अट्रैक्शन. विच एटम, किस एटम के वैलेंस इलेक्ट्रॉन वुड फेस द लीस्ट अट्रैक्शन फ्रॉम द न्यूक्लियस?
सर जिसके सबसे ज्यादा शेल्स हैं. So potassium over here.
Yeah. Here in this example is potassium, because potassium का ये वाला जो वैलेंस इलेक्ट्रॉन है, I hope I am able to convey this in the, so if potassium का ये वाला जो इलेक्ट्रॉन है, this electron of potassium would face the least amount of attraction from the nucleus. If this electron faces the least attraction, what do you think? This, अगर मैंने इस इलेक्ट्रॉन को रिमूव करना है, I want to remove this electron from lithium, this from sodium and this from potassium, तो मुझे सबसे ज्यादा एनर्जी किसको देनी पड़ेगी? Yes, जन्नत. Which atom among these three would require highest amount of energy to remove this electron? देखो इलेक्ट्रॉन रिमूव करने के लिए एनर्जी तो चाहिए, because they are being attracted by the nucleus. किसको सबसे ज्यादा एनर्जी चाहिए होगी? Lithium. Excellent, because lithium is smaller in size. The valence shell is closer to the nucleus. So as you go down, आपको याद है आपने group 1 में पढ़ा था periodic table में, as you go down in group 1 the reactivity increases. तो वो reactivity क्यों increase होती थी? Because atomic radius बढ़ रहा है, nuclear pull decrease हो रही है, so it is easy for us to remove the electron from as you go down. तो जब electron easily remove होगा, it is more reactive. So out of these three, potassium is more reactive because it can lose electron easily, because its valence electron faces very less attraction from the nucleus. I hope this makes sense. Yeah. Yes. So, yes, Mayan.
Sir, I'm really sorry, मेरा actually net lag हो गया था. आप repulsion के बारे में क्या कह रहे थे? Repulsion and shielding effect के बारे में?
Yeah. So basically, repulsion is always caused by the inner shell electrons. Greater the number of inner shells, greater are the number of inner shell electrons. They cause more repulsion to the valence shell electron. They goes away. Atomic radius increases. Yeah. All right.
Sir,
Let's talk about इसको shielding effect कहते हैं. This repulsion due to inner shell electron cause, which is by which valence shell faces that repulsion. This whole idea is called shielding effect. Let me write the definition of shielding effect over here. I want everyone to look and note if you have something to write. Shielding effect. Now, a decrease in the force in the nuclear attraction, a decrease in the nuclear attraction for the valence shell electrons, due to, so what should I write in due to sentence? It is a decrease in the nuclear attraction for the valence electron due to, please help me complete the sentence. Due to what? Due to the inner electrons or inner shell electrons. So greater the amount of inner shell electrons, greater is the repulsion, more is the shielding effect. So a decrease in the nuclear attraction for the valence electron due to the inner shell electrons. Make sense, everyone? So basically, shielding effect increases number of inner shells. बढ़ेंगे तो shielding effect भी क्या होगा? बढ़ेगा. तो जब shielding effect बढ़ेगा, atomic radius क्या होगा? वो भी increase होगा. जब atomic radius increase होगा, तो ionization energy क्या होगी? This is basically half of the chapter जो मैंने यहाँ पे लिख दिया. Ionization energy होती है energy required to remove an electron. तो जब atomic radius बढ़ेगा, electron remove करना easy हो जाएगा. तो हम कहेंगे energy required to remove electron decreases as the atomic radius increases. Make sense, everyone? Yes. So if inner shell electron increases, the shielding effect increases. Shielding effect increases, atomic radius increases. Atomic radius increases, the ionization energy decreases. Ionization energy क्या है? It is the amount of energy needed to remove the electron from the valence shell of an atom. Now let's discuss the trend of atomic radius when you go across the periods from left to right. Right? So let me write all the elements in any specific period, because period 3 is part of our syllabus. So let me write the same period here. So you see sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, and argon. These are all elements of period 3. Let's write the electronic configuration. अभी हम कल की क्लास में we will learn a new method to write the configuration inshallah. But क्योंकि अभी हमने O levels वाली पढ़ी हुई है तो मैं वही लिख लेता हूँ. This would be 281. This would be 282, 283, 284. ऐसा ही है ना? O levels में यही लिखा था. And that would be 2, 8, and 8. Make sense, everyone? ये तो सबको आती है ना, how to write the basic configuration of atoms. So what is common here? I want everyone to think of shielding effect for a second. I want Jenna to respond. What happened to the shielding effect if you go across the period? Considering the concept of number of inner shells, shielding effect, atomic radius, and ionization energy. So what happened to the shielding effect?
Remains constant.
Excellent. If you look at the inner shell electrons, the inner shell electron does not changes inside the same period. The inner shell electron is same until the shell is completed and you are on the noble gases. So going across the period, number one, the thing that we have noticed here is the shielding effect. So Jannat says shielding effect remains same or remains constant, right? What is changing here in terms of the subatomic particles? Who would like to respond? Sarim, what is changing here in terms of subatomic particles?
Electrons are increasing.
And
also
when
protons.
electrons are yes. So देखो, imagine tug of war. In sodium, we have 11 protons, Aksa. If there are 11 protons, we must have 11 electrons. So 11 log idhar hai, 11 log idhar, they are attracting each other. Next atom mein we have 12 protons, 12 log idhar hai, 12 log idhar. So protons nucleus mein बढ़ रहे हैं, nuclear charge बढ़ रहा है, और उसी same shell में, the same third shell change नहीं हो रहा, same shell में electrons add हो रहे हैं. Shielding effect same है, shielding effect तो change हो ही नहीं रहा. अंदर proton बढ़ रहे हैं, positive charge, in the same shell we are adding electron. So the nuclear attraction would become more stronger because we are adding more particle with the opposite charge. So tug of war mein pehle 11 log the 11, we have 12, 13, 14, 15. Imagine having 17 protons and 17 electrons. So they would attract strongly the outer shell electron. So what do you think about the atomic radius? Let's imagine if this is the size of sodium, predict the size of let's say chlorine. Would it be bigger than this? Or do you think it would be smaller than this? A or B? What is the correct answer? Aksa. If this is sodium, what could be chlorine? Would it be A or B? And why? Dr. Aksa. Shabash. I want everyone to look, try and make logic out of it. The concept we have just explained about the shielding effect, about the proton being increased in the nucleus and the electrons are being added in the same shell. What happens to the size? I think Aksar was into internet issue. Yes, Ryan. Rania bhi hamare saath hai, just realized.
सर छोटा होगा क्योंकि आपके पास इलेक्ट्रॉन्स भी बढ़ रहे हैं, आपके पास प्रोटॉन्स भी बढ़ रहे हैं, अट्रैक्शन ज्यादा हो जाएगी वो, और शेल सेम है आपके पास, तो इट विल पुल इट इनवर्ड्स.
Yeah, excellent. So I hope, Rania, this makes sense. And everyone, look, you are increasing the protons in the middle, you are using electron in the outer shell, oppositely charged बढ़ रहे हैं, so they are definitely going to attract with a greater pull, and the atomic radius decreases as you go across the period, and for obvious reasons. And the reasons are the shielding effect. हम start यहाँ से करेंगे reasons को. The proton increases in the nucleus, the proton number increases. Electrons, also the electrons added in the same shell are added to the same shell, shielding effect remains same. यहाँ पे बात इसको उठा के इधर ले आते हैं. Shielding remains same. So what would happen to the net nuclear attraction? So net nuclear attraction increases. Net nuclear attraction increases. I hope you people are not getting bored. पहली क्लास आपने कहा सर पढ़ाई जा रहे हैं यार, पढ़ाई जा रहे हैं, ब्रेक ही नहीं दे रहे भाई. दिस इज वेरी इंपॉर्टेंट, एज आई सेड, बड़ा इंपॉर्टेंट टाइम है. आपको ब्रेक भी मिलेगी, बहुत सारी चीजें मिलेंगी, बट दिस इंपॉर्टेंट कॉन्सेप्ट will help you to answer all the questions from many topics, including the atomic radius, including the reactivity. Even in A2, we have topic called electron affinity. So this important concept of understanding how does the atomic radius changes top to bottom and across the period will help you answer many questions. So I hope you all have understood the idea that why it increases top to bottom for these reasons, and why it decreases across the period for some reasons. So, and let's say we have sodium here, we have magnesium here, and we have aluminum here. And for sodium we have 1 electron, magnesium we have 2 in the valence shell, aluminum we have 3. So what do you think if I need 1 electron and we have 3 people, sodium, magnesium, and aluminum? Rania, if your mic is working and you want to respond. If I need 1 electron and I have 3 people, sodium, magnesium, which person, which element out of these 3 would lose electron very easily, and why? चलो why छोड़ो, ये बताएं कि which of these 3 particles can give electron easily?
Sir, I think aluminum.
Aluminum, you think aluminum can lose electron easily? Imagine, let me just draw the nuclei. अच्छा मैं इनको बना देता हूँ. This is sodium, magnesium, यहाँ पे aluminum में लिख देता हूँ, and these are their nuclei. Imagine nuclei, इस nuclei के पास 11 protons हैं, this has 12 protons, and this have 13 protons. So देखो यार, यहाँ पे इसके protons भी ज्यादा है, it has more protons, and also the valence electron is close to the nuclei. So if it has greater nuclear charge and also close to the nuclei, तो बेटा ऐसा नहीं होगा कि this electron will be strongly attracted by the nuclei, because it is close to the nucleus, and also the nucleus is more powerful with 13 protons. So अगर ये करीब भी है और इसका न्यूक्लियर भी ज्यादा पावरफुल है, ये तो इलेक्ट्रॉन निकालने के लिए हमें बहुत ज्यादा एनर्जी लगानी पड़ेगी, isn't it? Yes, Rania?
Yes, sir.
Yeah. So इसका मतलब ये है कि you need to look at the radius. Atom with a larger radius, so this electron is away from the nuclei compared to this electron. So when you go across the period, ability to lose electron decreases. First atom of the period can lose electron easily, और उसकी आयनाइजेशन एनर्जी सबसे कम होती है. इसको ज्यादा एनर्जी देनी पड़ेगी, उससे ज्यादा, उससे अगले वाला उससे भी छोटा होगा, so require more or small. Or so as you go across the period, energy required to remove electron increases, and for these valid reasons जो मैंने आपसे डिस्कस की, जब net nuclear attraction increase होगी, तो it would become difficult for us to remove the electron. Everyone, make sense? Say yes, please. Everyone.
Yes, sir.
Yes, Dr. Jannat, Mr. Rayan, Sir Sarim, and who else is
yes.
here? अक्सा का
Yes,
तो
sir.
माइक ही नहीं काम कर रहा. अक्सा, will gift you a mic, don't worry. मैं आपके बाबा को कहता हूँ इनको एक mic gift करें. So let's review the entire thing we've studied today. This is very important. And all right, I'm glad that you're taking the notes, mashallah, Aksa. So just a second, Rayan, let me just help me. Acha, Rayan, help us to review the entire thing we studied today, starting from the atomic structure, since you're there in the beginning. कुछ लोगों ने late join किया. Yes, Rayan.
So, sir, actually, हमारे पास एक atom होता है. Atom has subatomic particles, which are electron, proton, neutron. उसके अलावा आपका जो atom होता है, that's mostly empty, क्योंकि shells बढ़ती रहती हैं. Shells होती हैं, shells are empty. उसके अंदर बस थोड़े electrons होते हैं. Most mass center में होते हैं, जहाँ proton and neutrons packed होते हैं. So that's why it's empty. बाकी जो subatomic particles होते हैं, proton is positive, neutrons are neutral, electrons are negative. अगर हम relative mass की बात करें तो electrons का होता है 1/1840, while proton and neutron का होता है 1 and 1. उसके बाद अगर ये आपने एक टेस्ट बताया था, इसमें अगर हम लोग न्यूट्रॉन को पास करेंगे तो it will go straight, इलेक्ट्रॉन को करेंगे तो पॉजिटिव तरफ अट्रैक्ट होगा, उसका मास थोड़ा कम है तो
अगर वो
ज्यादा।
आपसे कंडीशन पूछे, एक्सीलेंट, अगर वो आपसे कंडीशन पूछे तो आपने बताना है द कंडीशन इज ऑल थ्री पार्टिकल मस्ट स्टार्ट विद द सेम वेलोसिटी, सेम टेम्परेचर, सेम प्रेशर। ऐसा नहीं है कि एक को आप ज्यादा गियर लगा दो, दूसरे को स्लो, उसमें से कम एनर्जी दो और फिर आप कंपेयर करो। व्हेनेवर यू आर कंपेयरिंग समथिंग यू नीड टू प्रोवाइड द सेम, सबके लिए क्या कहते हैं, रूल ऑफ लॉ मस्ट बी सेम फॉर एवरीवन। सो अक्सर यू मस्ट need to change your internet connection. So this is how you can compare the relative masses and charges. I mean, it's the exact same thing that you did learn in your O levels. Distribution of charge and mass is something new, but हमें ये idea है most of the mass lies inside the nucleus, while the charge is distributed evenly with positive charge in the nucleus and negatively charged particle surround the nucleus, revolve around the nucleus. This is something which I want everyone to understand. कल जब क्लास होगी तो इससे मैं पास्ट पेपर क्वेश्चन भी आपसे पूछूंगा। The idea of atomic radius is in the group it increases and in a period it decreases, and the shielding effect plays a major role here in the decrease or increase in the atomic radius. In the groups, as you go down, extra shell is added. So because of that, the shielding effect increases and outer shell goes more away. So net nuclear attraction decreases. We can say that the atomic radius increases. What is shielding effect? It is a decrease in the nuclear attraction because of the inner shell electron and outer shell goes away. This is a very important relation between everything part of this atomic radius. In the periods, atomic radius decreases because as you go across the period, the proton number increases, so does the electron, which are added to the same outer shell. Shielding remains the same. All these three factors makes net nuclear attraction more stronger. So as you go across, nuclear attraction increases, because of which outer shell gets more closer to the nuclei, atomic radius decreases. Any question? Yes, please. I would be. So इंशाल्लाह कल भी आप कुछ लोग लेट आए थे, कल से हमारी क्लासेस हैं। आई नो आपको स्केड्यूल सबको पता है, इट इज मंडे, ट्यूसडे एंड थर्सडे। सो कल आप सब लोग ये रिव्यू करेंगे बिफोर द क्लास, यू विल गेट द नोट्स। अभी मैं ग्रुप में ये फॉरवर्ड कर देता हूँ, क्योंकि अभी चैप्टर कंप्लीट नहीं हुआ, तो जब हम चैप्टर कंप्लीट करेंगे देन यू विल गेट, एक वर्कशीट मैं करूंगा, 2-3 आप करेंगे, मिलकर हम उनको डिस्कस करेंगे इंशाल्लाह। सो थर्सडे 8:15 का मतलब है 8 o'clock। आप सब, मैंने कहा था 15 मिनट्स पहले आप अपने रूम में बैठें, टेबल पे बैठें, रिव्यू द प्रीवियस लेसन सो दैट यू कैन, इफ यू हैव एनी क्वेश्चन आप उसको अपनी नोटबुक पे लिखें, दिस इज व्हाट आई एम गोइंग टू डिस्कस विद टीचर। अगर ऐसा नहीं होना चाहिए कि मैं 8:15 पे आऊँ एंड आई वेट 10 मिनट्स और 15 मिनट्स एंड देन यू पीपल आर जॉइनिंग, ब्रश में है, कहीं बाहर से। ट्राई टू मेक दीज लेसन्स मोर प्रोडक्टिव फॉर यू पीपल, इट इज फॉर यू पीपल। मुझे थोड़ी बहुत केमिस्ट्री आती है, हम मिलके इसको और सीखेंगे, but it is going to benefit you people inshallah in the longer run. Yes, Ryan. So class is over. If someone has any question, he or she can stay or you can leave. We will have another class inshallah on Thursday, same time. Allah Hafiz. Yes, Ryan.